Every land animal alive today can trace its existence back to a single crossing. One group of creatures left the water. What happened next became every insect, every forest, every mammal, and eventually you. Most people picture it as a fish heroically dragging itself onto a beach. That image is wrong in almost every important detail. To understand what really happened, you need to picture Earth as it was. The Devonian period, roughly 419 to 359 million years ago, is sometimes called the Age of Fishes. The continents looked nothing like today. No familiar shapes. No polar ice caps. And land was not bare, empty rock. Plants had already colonized the land, tens of millions of years before any animal arrived. Primitive forests were pulling carbon from the air and breaking rock into the first real soils. Those forests were full of life. Insects, millipedes, early spider-like creatures, and no animal with a backbone had ever touched them. That untouched food supply was going to matter. Nothing left the water for over 3 billion years, and for very good reason. Water handles gravity for you. Your body floats, and your muscles don't fight your own weight. It keeps you hydrated automatically. Gills extract oxygen directly from water flowing over them. Reproduction is easy. Release your eggs, let the water do the rest. Stepping onto land meant losing every one of those advantages simultaneously. For billions of years, water solved life's biggest problems so well that leaving it looked almost impossible. So what did it actually take to survive outside the water? Gravity was problem one. Without buoyancy, a body collapses under its own weight. Drying out was problem two. Step into open air, and your body loses water immediately. Breathing was problem three. Gills collapse in air, and oxygen exchange falls to almost nothing. Reproduction was problem four. Eggs need water to survive and fertilize. Every single challenge had to be solved, and most had to be solved at the same time. Evolution didn't plan a solution. It found one incrementally over millions of years. And here is the first major thing you probably have wrong. The first animals to establish themselves on land were not fish. Not any animal with a backbone. They were arthropods, animals with external skeletons and jointed legs. Like insects, millipedes, and spiders, their external skeleton was the key. It resisted drying out and supported the body against gravity. The strongest candidate for first confirmed land animal is called Pneumodesmus pneumoni. It was a millipede-like creature, discovered in Scotland, roughly 428 million years old. Its fossils contain what appear to be spiracles, tiny breathing holes that pulled air directly in. Vertebrates, the fish ancestors that eventually produced us, followed tens of millions of years later. If that surprised you, that millipedes got there before any fish hit like. There are more stories like this, things you think you know that turn out stranger. Subscribe and we'll keep making them. Now, back to the fish that eventually came after those millipedes. When vertebrates did begin the transition, it unfolded through a sequence of increasingly strange fish. The sequence starts with a fish called Eusthenopteran from 385 million years ago in Quebec. It was completely a fish. Scales, fins, lived entirely in water. But inside its fins were bones directly equivalent to your upper arm, your forearm, and your wrist. The blueprint for your skeleton existed inside a fish 385 million years ago. Next came Panderichthys from 380 million years ago in Latvia, flat-headed with eyes on top of its skull. It was built like an ambush predator, lurking at the very edge of shallow water. Detailed scanning in 2008 revealed something unexpected at the very tip of its fin. A finger-like structure, the earliest hint of a digit, already forming inside a fish. Something in those weedy, shallow environments was rewarding fish that could push and grip. Then, in 2004, came the discovery that changed how scientists understand the entire transition. 3 paleontologists didn't find it by accident. They predicted exactly where it would be. Their reasoning was specific. Rocks from around 375 million years ago should hold the answer. They identified Arctic Canada as the right geology, mounted expeditions, and spent 5 field seasons searching. They found exactly what they predicted. They named it Tiktaalik rosie, an Inuktitut word for large freshwater fish. Tiktaalik had scales, fins, and gills, unmistakably a fish. But it also had a mobile neck, a flat crocodile-shaped head, and robust fins with a built-in wrist. It could prop itself up on those fins and support its own weight. It was a creature balanced exactly at the boundary between fish and land animal. The discovery proved that evolutionary theory doesn't just describe the past, it predicts it. But the most important finding in this whole story doesn't involve Tiktaalik at all. It involves a creature called Acanthostega from East Greenland about 365 million years ago. Acanthostega had 4 true limbs, actual fingers and toes, not fins. Scientists assumed this meant it was walking on land. Paleontologist Jennifer Clack spent years proving that assumption completely wrong. Its wrist bones were too loosely connected, its shoulder too fish-like to bear weight on land. This animal almost certainly spent its entire life in water, using those limbs to move through weedy shallows. Fingers and toes evolved first in water, not for land, for underwater. We had the story completely backwards. And Acanthostega had 8 fingers and toes on each limb, not the 5 we all carry today. Then, in 2010, came another discovery that pushed the timeline even further back. A research team published fossil trackways from the Holy Cross Mountains of Poland. The tracks showed clear finger and toe impressions and a walking gait, made by a 4-limbed animal. The rocks were 395 million years old. That's nearly 18 million years older than Tiktaalik. 4-limbed animals were already walking before the creatures we thought were their ancestors had evolved. The fossil record isn't just incomplete. It may be showing us only a fraction of the real story. So why did vertebrates eventually leave the water at all? The old explanation was drought. Fish trapped in drying pools crawled overland to find water. But Acanthostega's limbs couldn't carry an animal across dry land. That theory fell apart. A better explanation: complex, shallow water favored animals that could push and grip in 3 dimensions. And when those animals raised their heads above the surface, something shifted. In water, you can see about 2 body lengths ahead. Raise your head above the surface, and that range multiplies to tens of body lengths instantly. Then there was the food. Invertebrates everywhere on land, with 0 competition from any animal with a backbone. For an air-breathing animal capable of brief land excursions, that was an open invitation. Everything in your body tells the story of that crossing. Every bone in your hand can be directly matched to a bone in a Devonian fish fin. The genes that built Tiktaalik's wrist are the ancestors of the genes that built yours. Your lungs trace back to air-breathing organs that fish developed while still living in water. The muscle that moves your upper lip traces back to the gill muscles of a Devonian fish. You're not descended from the story in some distant, abstract way. You're carrying that Devonian crossing in your body right now. The story of the first animal on land is really about where everything familiar came from. Ground beneath your feet, hands that grip, air in your lungs. You don't have to go looking for proof of that crossing. You are the proof. And somewhere, under rock that hasn't been found yet, there is an older footprint, still waiting. See you in the next one.